In this lesson, we're going to be talking about refrigerant safety. Okay, refrigerants are really strange because the liquid coming out of the cylinders as it boils off is really cold. It's also, refrigerants are a combination of many different chemicals, some of them which can kill you. Okay, in refrigeration machines of early 1900s, okay, they were the first machines that used refrigerants that were toxic and highly reactive. Okay, as time went on, we began to develop non-toxic, non-flammable refrigerants referred to as fluorocarbons. That's still what we use today. Little did anyone know that these supposedly safe refrigerants, they also contain chlorine and were slowly damaging the ozone layer. In the early 80s and late 70s, to reverse this trend, the phase out of these chlorinated refrigerants has led to the development of totally new refrigerants, as well as the increase of using long-lasting refrigerants such as ammonia. The specific hazards of each refrigerant we deal with can be determined by referring it to its Material Safety Data Sheet, or MSDS. Refrigerant safety ratings are designed by ANSI, or ASHRAE standard 34-2010, help provide a simple breakdown for toxicity and flammability of refrigerants. So the first place to begin with any new refrigerant you use is to review the Material Safety Data Sheet. The MSDS will accompany any newly purchased refrigerant cylinder if requested, or they can all now be downloaded and accessed from the internet. Refrigerant MSDS sheets will vary slightly depending on the manufacturer, but they all contain similar information. The first section of the MSDS that contains the chemical product and company identifier, and it will also have an emergency overview and a number to call if you need help. Section 3, Hazard Identification, provides a listing of potential hazards to the skin and eyes from inhalation. Section 4 contains first aid measures, including first aid for the skin, eyes, inhalation, and indigestion, along with advice for the physician. All of this information is important in the event of an emergency and may need to be referenced quickly. There's one of the main reasons to review the MSDS sheet ahead of time. Section 8, it contains exposure controls, personal protection, and lists the exposure controls and personal protective equipment and required for handling refrigerants. You have to look at stuff like gloves, goggles, breathing apparatus for respiratory protection are listed, along with any additional recommended or special equipment. Other important sections include 5, 6, and 7, which includes the firefighting measures, accidental release measures, and handling and storage. Section 9 contains the physical and chemical property and lists important information such as pressures and boiling points. Now, it's important to protect yourself whenever you're working with refrigerants. Refrigerant hoses can fail, fittings can leak or burst, and that can cause refrigerants to come in contact with your skin or eyes. Safety glasses that are impact and shatter resistant should be worn whenever working with refrigerants. Protective gloves should be worn whenever handling refrigerants, and they should not only protect against exposure, but also resist physical hazards such as abrasion and cuts. Generally, leather gloves that fit properly provide adequate protection for common refrigerant work. Now, with refrigerants, the reason we're so worried about skin exposure, again, if liquid refrigerant hits your skin, it's under pressure coming out of the bottle. As soon as that pressure is released from the cylinder, it's going to start boiling off. As refrigerant boils, it gets cold because it absorbs whatever heat's around it at the lower pressures, and it will actually freeze whatever it's touching. Most refrigerants boil at negative, like 20, 40, 50, 240 degrees Fahrenheit. So you can imagine that is almost instant flash freeze of your skin. A self-contained breathing apparatus is a device worn by rescue workers, firefighters, and others to provide breathable air in an immediate danger to life and health atmosphere. The term self-contained means that there's a high-pressure tank or regulator, and therefore a long supply hose from an external source is not required. If a refrigeration spill occurs, then an approved self-contained breathing apparatus must be worn whenever entering the space if the refrigeration contents are above the permissible limits. Letting liquid refrigerant come in contact with the skin can burn you. Technicians should wear neoprene-lined gloves and goggles to protect their hands and eyes from exposure. R410A, as I said, boils at negative 62.9 degrees Fahrenheit at atmospheric pressure. Skin exposed to this direct liquid stream for only a minute can receive severe frostbites that act like a second or third degree burn. Keep your hands out of stream of liquid refrigerants. That means if something's leaking, all you can do is get out of the area, ventilate, and let it leak. There's no way you can ever stop a refrigerant leak, nor should you try with your fingers. The other thing you have to worry about is asphyxiation. Most refrigerants are heavier than air and will displace the oxygen in a room. Large amounts of refrigerant released into a room can cause suffocation, which is asphyxiation. Most refrigerants are odorless, so there can be no outward signs other than the person becoming lightheaded. Okay, all commonly used refrigerants except R717, which is ammonia, and water, R718, are heavier than air. More than 80% of all ammonia produced is used for agricultural purposes. Less than 2% is used for refrigeration. It must be 99.98% pure, and it has to be dry to prevent freeze-ups. Ammonia will attack and rust away, corrode copper, zinc, and alloys of copper and zinc. However, ammonia can be safely used as a refrigerant provided the system is properly designed, constructed, and operated and maintained. You have to think about a couple things with refrigerants. Unlike most refrigerants, ammonia is lighter than air and rises. Pure ammonia vapors are fire and explosion hazards at higher concentrates of approximately 15 to 28%. When mixing lubricating oils, its flammability increases even further. This is a chart of the ammonia exposure threshold starting at 5 ppm, okay, all the way up to 5,000 ppm. That's parts per million. Okay, at 400 parts per million, compared to room air or regular air, you're going to have major throat irritation. And then at 5,000 ppm, you'll have respiratory spasms, and it's rapidly fatal. This is for the effects of ammonia. It's nothing to mess around with because like 300 parts per million is considered an immediate danger to life and health. Ammonia is widely used in large industrial refrigeration systems because it has a high net refrigeration effect and low impact on the environment. However, most fatal refrigeration accidents have a result of a sudden release of ammonia. Okay, between 1984 and 2006, there were 224 accidents and 50 fatalities involving the release of ammonia in the United States. Okay, ASHRAE in ANSI Standard 34-10 talks about refrigerant classifications, addresses refrigerant safeties. It's a number and letter combination. A identifies refrigerants with low toxicity. B identifies refrigerants with high toxicity. The number 1 to 3 follows the letters is used of flammability of the refrigerant. How easily does it burn? The number 1 would be low flammability, while number 3 is high flammability. So if we look at the chart, which is much easier, if we have a refrigerant that's a B3, that's an extremely high toxic and high flammability. Most of our refrigerants that we use are in the A1 group, okay, because we want them very low flammability and low toxicity. Almost anything can be high toxic in high quantities. Okay, the example the air we breathe is 78% nitrogen. However, breathing 100% nitrogen will cause asphyxiation. Toxicity is defined in the ability of a refrigerant to be harmful or lethal due to acute or chronic exposure by contact, inhalation, or ingestion. The maximum safe exposure limit in parts per million by volume is called the threshold limit value, okay, or TLV. The time-weighted average concentration for a normal 8-hour day, 40-hour week that is safe for any adverse effects is referred to as the threshold limit value time-weighted average. This is often commonly expressed as the occupational exposure limit. Again, occupational exposure limit, we're talking about a 40-hour work week, 8-hour day, 40-hour week, because that's what most people work in an industrial environment. So the 34-10-2010 safety groups, R10 is a B1. R22, which is actually what we use in a lot of residential systems, is an A1. R12 is also an A1. You're going to find that the majority of refrigerants that you're going to be using are in the A1 unless you deal with ammonia. Okay, so again, all of our mixes, our 134As, our R407s, R410As, are pretty much in the A1 classification. Again, lower toxicity. They can still kill you if you're in a room full of them and don't have oxygen, and low flammability. We don't have to worry about refrigerants for the most part if it's an A1 catching on fire burning. We do have some safety concerns that arises from the interactions of refrigerants. For example, CFC and HCFC's refrigerants are not flammable, but they chemically decompose when exposed to flames or very high temperatures, and they release chlorine and fluorine. Okay, this creates a highly irritating and potentially toxic gas, including chlorine gas, fluorine gas, and phosgene gas. Okay, so CFCs and HCFCs, you only want to braze line sets that are empty, first of all, because of pressure regulations. You don't want them to blow apart when you heat them up just from pressure. But you also don't want to burn that refrigerant because the phosgene gas can actually kill you. Okay. HCFC and HFCs can react violently with some metals. They should never come in contact with magnesium. Okay, HFC refrigerants should not be allowed to come in contact with freshly braided aluminum. Some HCFC refrigerants are flammable under high pressure with large concentrations of oxygen. Oxygen or compressed air should never be put into a refrigeration system. The oxygen under pressure can cause an explosion when mixed with the refrigeration oil. So that is why we only pressure check with nitrogen. We never pressure check with oxygen or compressed air. Refrigerant cylinders need to be stored and transported safely. They come in different sizes and are color-coded. Okay, they contain both liquid and vapor under pressure, so they'll always have some sort of burst protection. There are three types of cylinders: non-refillable, refillable, and recovery. This is a non-refillable cylinder. Department of Transportation controls how these cylinders are designed and how they're stored. They come with a check valve. They should never be refilled. Okay, it's a non-refillable cylinder used once. That's what your virgin refrigerant comes in. Okay, this is just an example of the check valve. Here's where you hook your hose up on this side, and there's a check valve in the center. Okay, these cylinders are this way for a reason. If someone were to try to refill a cylinder, a danger of explosion exists. Also, danger of potential penalty is up to $500,000 and 5 years in prison for refilling a disposable cylinder. Don't store or use these in temperatures exceeding 125 degrees, so watch your trucks when you park them in the sun. Most DOT-39 cylinders have a service pressure relief of 260 psi, and the pressure relief is stamped into the side of the can. Okay. Disposable cylinders can be recycled once all the refrigerant is removed from them. Once that's done, the cylinder valve can be opened, and a metal chisel can be placed on the rupture disc located at the top of the tank and open that rupture disc. You do not want to toss one of these cylinders out without it being permanently opened, so no one can pull it out of the dumpster and reuse it. Refillable cylinders, okay, are available, but only the owners of the cylinders or a company can refill them. You cannot take refrigerant from one source and sell it to someone else. Okay, they usually have 123 pounds or more of capacity. Recovery cylinders are available at capacity of 27 and 47 pounds. They're marked with DOT specifications for the cylinder. The numbers and letters immediately following the letters DOT describes how the cylinder is made, and the last group of numbers describes the cylinder pressures. Okay, so again, DOT controls the recovery cylinders. The relief valve is designed to open at 150% of the rated pressure, and these valves reset once the pressure drops back to a low level. So again, be careful with refrigerants, know the safety requirements, review the MSDS, and whatever you do, do not inhale or get liquid refrigerants on your skin. It's